everybody. Hi. Alvaro's speaking up next with Learning Electronics and Software the Rainy Way.
Can you hear me all right? Okay, I can hear myself, but I don't know. That happens normally. All right, so yeah, this talk is, last year my talk was Learning Electronics and Software the Cheesy Way, so I thought I'd augment on that. Yeah, so the rainy way, question mark. So this is about the two-year journey of making a weather station and kind of the lessons I learned along the way. It all started when I don't know how I found this website, but the Switch.doc Labs has this whole weather station project. And I saw it and it looked pretty cool. And then I looked inside of it and it's kind of a mess of things, right? It's got like Raspberry Pis, it's got all these cables and different individual modules for everything. And I thought to myself, oh, I'm an engineer. I could do this better, right? I could like make everything all, put it together in one thing. So I started and I bought their kit just for the top part. And you can see this in my lab at home. And just going to explain it really quick. You have an anemometer, wind speed sensor. Then you have wind direction. Then you have a rain gauge there, and temperature, humidity, that kind of stuff. This came with its own controller that already was working and it had Wi-Fi and whatnot. But I wanted to, improve it. Oh, here was supposed to explain how this works. So this is a rain gauge. Actually, it's a tipping bucket rain gauge. So it fills up, and then it tips, boop, like that. And then every time it counts, it clicks. The wind speed, every time it turns, it sends a pulse. The wind direction is different resistance depending on the position. So I started and I made these kind of integrated boards, as you can see here. And it's using an NRF52, just Bluetooth. And it has these RJ11 or 14 connectors for the wind speed and direction. And from the start, I started having issues. So as you can see here, my footprint was incorrect. So I had to do some cutting around and fixing things. So again, lesson of always is check your footprints like 3 times at least. Yeah, so I started like this. It worked with Bluetooth, and I didn't do anything with it. I just lost interest and forgot about it until this year, I guess. Or no, yeah, December last year. So I set myself new rules. I'm just going to get something working no matter what. I don't care if it's using everything off the shelf, if it's totally different, like the original one I made. I just wanted it to work at first. And my biggest issue is premature optimization. It happens a lot. I start optimizing everything, try to make it as low power as possible, as small as possible, and then I just don't do it. So I started with the ST micro Nucleo boards. It's kind of I don't want to say an Arduino on steroids, but there's different microcontrollers. It's just a development board. And I started using the ARM embed software, which is kind of also Arduino on steroids. C++ libraries, they had a web compiler, and tons of libraries to kind of pull from. So then I made a breakout board for it. I was like, all right, I already have this working. I'm going to make this breakout board. It's going to use an XB radio, which is standard, like off-the-shelf radio. It's not cheap, but it works. And then I'm using off-the-shelf pressure sensor, off-the-shelf temperature sensor, all that stuff. So yeah, here's your pressure sensor. First mistake I made this board, and eventually it's going to run out of battery, but I didn't have a way to measure how much power it's using. So I had to cut some traces, Over here, another mistake I made is the XB, when it's just idling, it's using like tens of milliamps, which is way too much for a battery-powered device. Luckily, it has a sleep mode that'll put it down into the hundreds of microamps, and I just forgot to connect that pin, because there's a pin that tells you if it's or not the one you use, and then I have to use that. I started out with this ginormous box. This is a 12-volt lead-acid battery. I'm using my bike stand to hold this up outside. It's got a GPS, because why not? It might run away. And just off-the-shelf, 12-volt to 5-volt regulator. and this waterproof box, and really high-tech cardboard, mounting in the back. So I did this. Oh, you'll see down here, I have a waterproof box. How do I get cables in and out? So cable glands. I never heard of these before. Oh yeah, I'm an electrical engineer, firmware engineer. I know nothing about mechanical engineering, so this is also me learning mechanical things. So cable glands, never heard of them. They're really neat. I got a million pack off of Amazon. It's just these things. So there's a little gasket in there. You put your cables through, you screw it down, and it kind of locks, or it just makes a seal around your cable. So it's super cool. Drilling holes in these ABS plastic cases with when you have like a 1/2-inch hole you need to drill, not good with just a regular drill bit. It just, bad things happen. So watching YouTube videos, I found out about these step drill bits, and they're used for kind of a machine or folded extra, not aluminum, just like folded metal stuff, but they work great on plastic, and it just kind of drills a little bit at a time, and you already have the measurements on the side, so it's pretty great. Another really cool tool I found was the automatic center punch. People use these to break glasses in cars, but it's also useful for marking down where you want to drill a hole. So you just kind of punch down on it. It's got a spring. Just push it, and then it just makes a little tiny dimple, and then you can align your drill bit on there. All right, so I have this gigantic box, this gigantic solar panel, and the little weather station. It's still, there was no sun in December in San Mateo, California, because I'm next to a hill. So I still had to charge the battery every week or two myself. But, it worked. The temperature humidity sensor has to be outside, because if it's inside the box, it's kind of not the right environment. You want to measure outside. So I made another high-tech Tupperware container rain shield. And you can see in the backyard, I have this PVC stand, just a bunch of folded pipes and whatnot. So Pvc Pipe Cutter, another tool that I didn't know existed until not that long ago. I used to use like a little saw to cut PVC pipe, and it sucks. This thing just ratchets. You close it, open and close it, and it just cuts right through the pipe. Fantastic. Another cool thing, just Google waterproof connectors, whatever. I needed a way to connect the solar panel in a waterproof fashion because it's going to be raining outside. But then I still had the problem of how do I connect this waterproof connector to the solar panel, because I have to strip the cable and then solder them together. And then you can do, it'll probably survive, but then I found out about these things, these solder sleeves. And it's heat shrink tubing, but in the middle it has solder, low melting point lead, and then it has glue on both sides. So you put the two cables. It's NASA approved, by the way, like NASA standards, but here's a better picture. You put the two wires, half stripped, and then you just heat gun, and it melts the lead, makes a connection, and makes it waterproof because of the glue on the sides. So it's pretty sweet. All right, so here's just a quick image of how it was working. The weather station was transmitting over XB to a Raspberry Pi, like that one over there, with an XB radio, and saving it all in a SQLite database, just using a Python script. So Python script's getting the data. Oh yeah, I'm also software stuff. Getting Python data and saving it to a database. And then I can SSH in from my computer over Wi-Fi, Raspberry Pi, and that's it. So here you go, here's a picture of what that kind of looked like. So this was the first version of the breakout board, so I made a new one. This one had a built-in GPS, because why not? I also added the pressure sensor instead of a breakout board, built it in there. I added before it was two different like phone jacks. So I found one that was 2-in-1. Oh no, what happened? The foot burns backwards. Again, the phone cable would go one way and then upside down on this one. It seemed like it was going to work, but it didn't, and so I had to do that. So just a picture comparing the two. You have your microcontroller board at the bottom, and then the breakout boards at the top. So here's a new version. Sometimes you have to work inside. It kind of fits in my living room. It works. What else do I have here? All right, so we had just saving it into a database is not that exciting. So I figured I should learn how to make a little website that plots all this data for me. And I hate the cloud, so all this is local. My Raspberry Pi is in my home network, and I can connect to it from phone or from my laptop. And then I use all these technologies, Python, SQLite, Balma is some CSS framework, whatever. Plotly lets me make plots, and Flask is a Python web server, and I like them. So let me see if this works. Yay! So you can see here, if you go to this website, you have, this particular one. You have your temperature, humidity, pressure, all that stuff. Solar panel is not connected. We had some issues while shipping. But you can also go look at plots. So here you can tell this room is actually colder than outside. Anyway, you have these plots. When I move it, the tipping bucket tips and thinks it's raining. But yeah, so now I'm able to plot this data, which is much more useful than not plotting the data, of course. All right, so I had that microcontroller development board. I decided, let me integrate it all in one. So this new board has a really huge capacitor because I used a reference design from SparkFun, from Adafruit. A solar charger. So you have a solar panel, it goes to a LiPo battery or lithium ion, and that's that thing in the middle there. And I am now using an STM32 microcontroller without embed. I decided to switch over to use Apache Minute, which is an open source little RTOS, a real-time operating system that has Bluetooth support, even though I'm not using Bluetooth. It also has a fan controller. That little one part there is a DC to DC converter from like 3 volts to 5 because I was driving a fan. I thought I was going to have to move air around. I was wrong. I didn't care about the accuracy, let's just say. Problem here, I misconnected it. My schematic was wrong, basically. I didn't pay attention to what I plugged in what. So that was bad. Another thing here, this was a fun bug. I had an external GPS connector because I was like, I don't really need it, but just in case. And I thought I was being clever. I used every pin that I could in the microcontroller, and one of the pins happens to be the bootloader pin. And you can set it to just be a GPIO. But it was floating. So every time the microcontroller turned on, it would sometimes go into the bootloader, sometimes not, and I didn't know about this. And it gave me a lot of fun debugging. I had other issues, should have checked my footprints again. That box was huge, so I tried to make it a little bit smaller. So I got a smaller box, and I found this YouTube channel called Modest Maker, and this guy makes external measurement things for some county and some state, I forgot. But he has a lot of great tutorials. So again, I used my high-tech plastic or cardboard to mount my circuit board, and you can see it there now. Exciting stuff. Oh yeah, cable gland. Make sure you put your cables through both pieces before you put your cables through. Otherwise, you have to take it off. Temperature humidity sensor. I didn't want it to get soaked, so I made this very high-tech again PVC pipe with a little plastic hat. You can see here the size difference between the original box and this one. And again, it's outside my backyard, mounted with some cables. All right, so this is version 1.0. Then I made another one. It's a little bit smaller. I added this MOSFET to basically turn off the wind direction and other sensors, because the wind direction is just a resistor. So it's always just eating up power, and I'm only measuring once a minute. That's the point. So this MOSFET just gates the power and lets me only measure when I want to. Some fun surface mount stencils are fantastic. A little oven. I'm just flying through these because I wait. All right, so here's the board again. Oh, new lesson. Measure, everyone says measure twice, do it once or whatever. I measured 3 times and I still did it wrong. I drilled the hole just the right length from the edge. It was just the wrong edge. I should have. Yeah, so you can see how that's for the solar panel. I just on the wrong side. Since I already had the hole at the bottom, that kind of determined which side was down. And I can't have, I don't know if, well, anyway, if the cable is too short for the solar panel, so if it would open, it wouldn't let me open the door, basically. Again, I upgraded from cardboard to plastic. This, I think, is from a strawberries container or box or something. Started mounting it again. Yeah, here we go. So you can tell if the solar panel cable was on the wrong side, it wouldn't let me open the box. The cable gland again. The solar panel cable was too thin, so I made it thicker with heat shrink tubing, and now it seals. Here it is again, outside, having fun. It rains. It survived. It never died because of water. I was pretty proud of myself. Here we go. And version 3 or 1.2, whatever. So here's a newer version. It has a bootloader button now, so I can boot into the serial bootloader in case something crashes. I was also able to use bootloading over the XP over wireless, which was fun. And I moved the solar panel connector just so it was better. Should have planned things out. I also explored with light, just environmental light sensing, because it'd be cool to see, maybe I can detect if clouds are going over or something. I don't know. But this has to be outside, and it's going to get wet, so I need some sort of protection around it. Never done conformal coating, so I said, why not? Ordered some silicone conformal coating, and I conformally coated the thing. And it works great. It's been outside for months. It's gotten rained on. The sun's been hitting it, and it's been fantastic. And this particular one, apparently you can even solder through it, which I don't know how that works, but it's pretty cool. All right, so I have a mostly working system, and then I traveled to Mexico, where my family lives. All this was a big scheme of getting my dad a birthday present, because he's a huge nerd, and he likes measuring things. So I took a clone of my weather station to Mexico, and we put it together. We wanted to make sure that bugs didn't get in there, because any sort of hole anywhere, bugs just live in it. Again, using household parts to waterproof things. These cable protectors are fantastic because the sun just eats everything away, especially close to the equator. If you leave anything in the sun, it just gets destroyed. So these plastic bits, I don't know what they're called. I should have written that down. Do great protection stuff. Here's my dad installing it in his rooftop. These are not the solar panels for the weather station, but so here you can see it. It's over there. It's on top of the house, and it's been running great. So anyway, I flew back, and I kept working on my version of it, I guess. It was working, but I always like making things better, so why not keep going at it? You can see that huge capacitor again. Don't need it. I can use a little capacitor, or I thought I could, and it's yes, I can. I modified this board, and I changed the microcontroller to back to an RF52, which is what I started with, which is Bluetooth. Pointing that out, you'll notice that now I have two radios, this was just a risk mitigation. I didn't know if I was going to have it working now. So I have Bluetooth and then the XB, and I did get it working, luckily. The reason I switched to Bluetooth was everyone has Bluetooth devices everywhere, so it's going to work. And Bluetooth 5, BLE5 now has a long range. They use a different coding. They call it the LE coding or whatever. And it lets you do much longer range at lower data rates, but like hundreds of meters, which is good enough for me. And then I don't need this whole module. In order to speak that, the Raspberry Pi doesn't have the new Bluetooth chip, so I made a little USB stick, which is over there. And of course, I flipped the power and ground on the USB cable or connector. Don't do that. But again, I want to get even smaller, and now my circuit board doesn't even. And here you can see the scale of the newest one and the older two. This time, I actually printed out my circuit boards to make sure everything fit. And now I'm using two different boards, one with the radio and one without. This time I was going to use an SMA connector on the outside of the case because the antenna before was inside. And I found this really neat waterproof SMA connector. Then on the inside, I have this, it's called MMCX connector to SMA adapter. Oh no, they're both the same gender. Okay, I can fix that. But now this looks ridiculous. It's just, so I found another thing that's just, it's called no ring. And that's going to hopefully be good enough. And here I am practicing how it's going to fit. Oh yeah, it fits. I use the KiCad SVG import. It's fantastic. So here's the new version of it. Now I just have the charger IC and then some of the sensors. And then I have a radio board. And I have the MMCX connector. But oh, this is dual-sided surface mount. How do I do that? Just stencil, solder, and then flip it around and lift it up. Another stencil. This is not an easy way of doing things, but I just wanted to see if I could. And it worked. So here's the latest evolution of this. TAC Connect. This is a great thing to program boards. It's just like pogo pins. That's great when you're doing single programming. But if you want to just leave it there to develop, there's this bottom thing that you use to hold it. Well, that didn't fit. I should have thought about that. Here's the smaller solar panel, because this thing uses like 100 microamps now, so it doesn't really need much. I'm using a joule scope to measure the current, and super useful. Making a new box, measure, whole bunch. All right. Oh yeah, this is great. So this is so tight that you can't really push things through. Like, you have to have the board outside to be able to connect everything. And these things don't fit. So I had to cut them to put them through. And then I learned all about crimping. And it's not that bad. This is a $10 TrendNet or whatever crimper. But then it worked. And then I put it in. Everything has to happen in order. If I have to remove the antenna connector to do this, that. Anyway, this is what it looks like. And that's what's here. And it's working. And without solar panel, it'll probably last a month. With a solar panel, forever. All right. So this is the way it was set up. So I wanted to access this from somewhere else as well as home. So I set up some server on DigitalOcean. Oh, no. So this was to manage my dad's one. My dad has a Raspberry Pi at home, and I want to be able to manage it. So I set up a server that one would connect to over SSH. So there's this thing called auto SSH. It just SSHs into my server, and then I can connect to my server and reverse connect to the Raspberry Pis. But this was not super reliable. So I found out about WireGuard, which is this really cool, lightweight VPN thing. And I'm going to do another live demo really quick. And now here, you can see from anywhere. This you can access on your phone. Let's see how the weather's in Mexico. And we can look at some plots. And for example, I can see how the temperature is over a week, over a month. And this is, my dad can still access it locally. And then my server just talks to his over a private VPN. So it's not even, there's no single point of failure, I guess. Here's some more of the technologies I used, and that's it. I finished. Sorry. Yeah, this is all open hardware, of course, open source. The GitHub is not super well documented, but it's there. Oh, I never explained Chak. Chak is the Mayan god of rain and thunder. It's like the Mexican Thor, if you will. So that's what inspired me to call the project. I'm going to be around all weekend if you have questions, because we won't have time for questions. So just talk to me if you want or not. Yeah. Thank you.